this part completely, when it rotates, this part, this entire hemisphere is receiving maximum amount of insolation. With southern hemisphere, most of the areas do not even receive any amount of insolation. Our atmosphere extends from the mean sea level to approximately 800 kilometers and beyond antanu ಹೇಳ್ತಾರೆ. Diffuse ಆಗಿರುತ್ತೆ. But yes, we have some elements of gases still there ಅಂತ ಹೇಳ್ತೀವಿ. ಹೌದಾ? Now ನೋಡಿ, if I take a unit column of air, probably 1 centimeter cube or 1 meter cube or whatever might be the unit. So ಏನ್ ಎನರ್ಜಿ ಬರುತ್ತೆ ನಮಗೆ ಒಂದ್ ray ಅನ್ನ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ ಬೆಂಗಳೂರಲ್ಲಿ ಒಂದ್ ray polar region ಅಲ್ಲಿ, the difference in the energy received will be massive difference. Correct alva? Whatever sir said is about convection. Convection andre due to disturbance in the molecules. Ade sorting, arrangement. Correct alva? Colder particles are always heavy, kelagade bandibitirtare. Warmer particles are always lighter, mele hogi. Just like there are fundamental bases in every topic. Let me tell you the fundamental base of climate. The fundamental characteristics, the fundamental elements of weather and climate at yavdu. Number 1, like what you said, temperature. And it is not just any form of temperature, it is atmospheric temperature. Howda? Atmospheric temperature source eno? Radiation. In short, called as insolation. The solar radiation enters our atmosphere, and our atmosphere is largely immune to the incoming solar radiation. The reason? The incoming solar radiation comes in as short wave electromagnetic radiation. Correct alva? But our surface of the earth is not immune to this. The surface of the earth, the lithosphere, is capable of absorbing the incoming solar radiation in the short wave category. Haudalva? Infrared category anta heltivi. Whatever, bidi. This surface retains that heat and then it re-radiates. Howda? Does it re-radiate it? Re-radiation. Now this re-radiation happens in the form of long wave. Pressure will decrease. Forget about pressure. We are not dealing with pressure now. Ade papa avagindavaru, he wants to say something. I mean, it's very good that you're contributing. Lighter particles will move up. Why? How is it related to whatever I'm explaining right now? It's not related, alwa. Long terrestrial. Okay, let me incorporate whatever you say. Let me do it. Ade long wave terrestrial radiation. I'm not discouraging your contribution. Don't think otherwise. Howda? Now this re-radiated electromagnetic wave in the form of long wave radiation, our atmosphere can absorb. Howda? They let this be our atmosphere. And this is the surface of Earth. The source, the principal source of heating, whatever you see, is from the bottom. Can I say Earth's atmosphere gets heated up from the bottom, not from the top? Howda? Have you ever thought about it, or do you know about this, that our atmosphere gets heated up from the bottom, not from the top? How many of you knew this? Gotita? Convection ಏನನ್ನೋ ಹೇಳ್ತಾ ಇದ್ರಲ್ಲ, ಹೇಳಿ. What is the evidence? What is the evidence? You feel more heat. Okay. Okay, hill stations are cooler. What he's trying to say is hill stations are always cooler. Our logic ದಯವಿಟ್ಟು connect ಮಾಡಬೇಡಿ. Hill station is closer to the sun because they are at an elevated place, so ಅಲ್ಲಿ heat ಜಾಸ್ತಿ ಇರಬೇಕು. In fact, that is not the case. ಹೌದಲ್ವಾ? The reason is Earth is always heated up from the bottom. The secondary radiation, whatever is re-emitted, that is the principle, that is the radiation that actually heats up our atmosphere. Okay, this is one element of weather and climate. Second element of our weather and climate is atmospheric pressure. Sir, whatever you were saying at that point of time, I think you mentioned about convection, correct? Howda? See, all this is the game of energy. Temperature is just the measure of energy. Howda? The degree of hotness or coldness, how much it is ಅಂತ ಒಂದು ಡಿಗ್ರಿ ಮೆಜರ್ ಮಾಡೋದು ಟೆಂಪರೇಚರ್ ಅಲ್ಲ. What are we measuring? Ultimately energy, heat energy. And we know a law. Energy can neither be ಅದನ್ನ ಹೇಳಿ ಬೈ ಹಾರ್ಟ್ ಮಾಡ್ಸಿರ್ತಾರೆ ಚಿಕ್ಕ ವಯಸ್ಸಲ್ಲಿ. ಅದನ್ನು 20 ಸತಿ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಅದನ್ನ ಬೈ ಹಾರ್ಟ್ ಮಾಡ್ಸಿರ್ತಾರೆ. ಎನರ್ಜಿ ಕ್ಯಾನ್ ನೀದರ್ ಬಿ ಕ್ರಿಯೇಟೆಡ್ ನಾಟ್ ಡೆಸ್ಟ್ರಾಯ್ಡ್ ಬಟ್ can be converted from one form to another form. Can energy be transmitted? Energy cannot be transmitted. Can it be transmitted? Can heat be transferred? Energy can be transmitted. Correct, alwa? There are three modes of energy transmission. What is that? Conduction. ಕೇಳಿದ್ದೀರಾ? ಇದನ್ನ ಬೈ ಹಾರ್ಟ್ ಮಾಡಿಸ್ಲಿಲ್ವಾ? ಮಾಡಿಸ್ಲಿಲ್ವಾ? ಮಾಡಿಸಿರ್ತಾರೆ, 100% ಮಾಡಿಸಿರ್ತಾರೆ. ಕಂಡಕ್ಷನ್ ಅಂದ್ರೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ ಇರಬೇಕು. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಕ್ಸಾಂಪಲ್ ಅನ್ನ ಕೊಟ್ಟಿರ್ತಾರೆ. ಟೇಕ್ ಅ ಸ್ಟೀಲ್ ರಾಡ್ ಆನ್ ದ ಆಪೋಸಿಟ್ ಸೈಡ್, ಹೀಟ್ ದ ರಾಡ್, ಯು ವಿಲ್ ಫೀಲ್ ಹೀಟ್ ಆನ್ ದ ಅದರ್ ಸೈಡ್ ಆಲ್ಸೋ. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಕನ್ವೆಕ್ಷನ್ ಅಂಡ್ ರೇಡಿಯೇಷನ್. Whatever sir said is about convection. Convection ಅಂದ್ರೆ due to disturbance in the molecules. ಅದೇ ಸಾರ್ಟಿಂಗ್, ಅರೇಂಜ್ಮೆಂಟ್. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಕೋಲ್ಡರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಆಲ್ವೇಸ್ ಹೆವಿ, ಕೆಳಗಡೆ ಬಂದ್ಬಿಟ್ಟಿರ್ತಾರೆ. ವಾರ್ಮರ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಆಲ್ವೇಸ್ ಲೈಟರ್, ಮೇಲೆ ಹೋಗಿರ್ತಾರೆ. ಅದನ್ನೆಲ್ಲ ಹೇಳಿದ್ದು ನೀವು. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಕಮಿಂಗ್ ಟು ವಾಟ್ ಇಸ್ ಪ್ರೆಷರ್. ಪ್ರೆಷರ್ ಲೈಫ್ ಅಲ್ಲಿ ಎಷ್ಟೊಂದು ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ಇರುತ್ತಲ್ಲ ನಮಗೆಲ್ಲ. ಪ್ರೆಷರ್ ಇದೆಯಾ ಸರ್ ಲೈಫ್ ಅಲ್ಲಿ? Anyone here who does not have pressure in their life? What kind of pressure? First of all, you should ask. Atmospheric pressure is what I would say. Everyone will be subjected to atmospheric pressure. Now, defining what is atmospheric pressure. What do you think is atmospheric pressure? Density. Sir, resistance. Resistance to whom? Resistance to what? Force, resistance. What is atmospheric pressure? ಗೊತ್ತಿಲ್ವಾ? ಫಿಸಿಕಲ್. ಸರಿ, ಬಿಟ್ಟಾಕಿ ಅಷ್ಟೇ. ಯಾಕೆ? ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಓದಿದ್ದೀರಾ ಪ್ರೆಷರ್ ಅಂದ್ರೆ ಏನು? ಪ್ರೆಷರ್ಗೆ ಒಂದು ಫಾರ್ಮುಲಾ ಹೇಳಿರ್ತಾರೆ, ಅದೇನು? ಈಗ ಫಿಸಿಕ್ಸ್ ಯಾವನ್ ಓದ್ಕೊಂಡ್ ಬರ್ತಾನೆ ಇವಾಗ? ಫಸ್ಟ್ ಇದೇ ಸಾಕಾಯ್ತು ಓದ್ಕೊಳ್ಳೋದು, ಫಿಸಿಕ್ಸ್ ಬೇರೆ ಓದ್ಕೋಬೇಕಾ? ಪ್ರೆಷರ್ ಇಸ್ ಸರ್ ಪ್ರೆಷರ್ ಇಂಟು ವಾಲ್ಯೂಮ್, ವಾಲ್ಯೂಮ್ ಇಂಟು ಟೆಂಪರೇಚರ್. ಹೊಸ ಈಕ್ವೇಶನ್ಸ್, ಹೊಸ ಥಿಯರೀಸ್ ಅನ್ನ ಕಂಡುಹಿಡಿತಿದ್ದೀರಾ? Pressure is nothing but force exerted per unit area. Force upon area. ಕೇಳಿದಿರಾ ಸರ್? ಮೆಕ್ಯಾನಿಕಲ್ ಇಂಜಿನಿಯರ್, ಸಾರಿ ಸಿವಿಲ್ ಅಲ್ಲೂ ಇರುತ್ತೆ. ಗೊತ್ತಿದೆಯಾ ಪ್ರೆಷರ್ ಏನಂತ? ರೈಟ್. If I am standing on this particular tile, am I exerting pressure on this tile? How? In what sense? I have a weight and this weight is being exerted in this particular area. So the pressure can be calculated. Howda? And when I add this term atmosphere to pressure, what does it mean? This blanket of gases that is surrounding the surface of the earth, correct alva? That is encircling the earth. Does it have a mass? Is it under the influence of gravity? Howda? Does gases have mass? Pakka? How do you know? It's a state of matter which has mass. Howdalwa? Just like solid, just like a liquid, gas will also have a mass. So do you think whatever the atmospheric gases are present over us is exerting a weight on us? Are they exerting a weight on us? Yes. And in comparison to the defined unit area, the amount of weight exerted by our atmosphere over our heads is what we call it as atmospheric pressure. Have you ever heard about the term atmospheric? Climatological contextually, low pressure, high pressure anta kelidira? Low pressure, some regions are having low pressure, some regions are having high pressure. Artha eno adardu? At that point of time, in that area, if the weight of the atmosphere is less, we consider that place to be having a low pressure. Correct alva? And if due to climatological processes or any process, if there is excess mass of air, correct alva, excess mass of air in a small unit area, what will happen to the weight at that point? Weight will increase. Correct alva? That region is said to have is being said to have been experiencing which pressure? High pressure. Correct alva? Pressure is always in context of movement of winds. Artha ಮಾಡ್ಕೊಳ್ಳಿ. Winds always move from a region of which pressure to which pressure? High pressure to low pressure. ಯಾಕೆ? Logic ಏನು? High pressure means more molecules, more weight. Excess ಇದ್ರೆ ತಾನೇ ಬೇರೆಯವ್ರು ಕೊಡೋದು. Excess ಇದ್ರೇನೋ ದುಡ್ಡು ಬೇರೆಯವ್ರು ಕೊಡಲ್ಲ ನಾವು. ಅದು ಬೇರೆ ವಿಷಯ. But nature is not like us. If it has something in excess, it will just give it away to the overall. Balance is what is arrived at. Correct alva? Wind always moves from a region of high pressure to, and it will balance it out. Correct alva? So that is some dynamics associated with pressure. And the third element, fundamental element of weather and climate would be atmospheric. ಏನದು? Pressure ಆಯ್ತು, temperature ಆಯ್ತು, ಇನ್ನೇನಿದೆ? Moisture, amount of water vapor present in the air. These three control all the atmospheric and climatic phenomena. Understand that? Okay, na? Let's give a brief description about Karnataka. Point ಏನಕ್ಕೆ ಇವೆಲ್ಲ ಹೇಳಿದಂದ್ರೆ, no matter what is the climatological interpretation or process or whatever you study, it's always an interplay of these three factors. Ade, you understand what is the role of these three factors, you will understand everything. Climatology should be visualized in that way. And please don't expect me to be very slow and gradual. This is something that is outside the domain of Karnataka geography that I have to incorporate in order to you better understand the affairs of Karnataka geography. Anyways, atmospheric temperature. What is the basic source? As I've already told you, the incoming solar radiation. Howdalva? And is this incoming solar radiation uniform throughout the earth? Is it very evenly distributed throughout the earth? No. Where is it distributed in excess and where is it distributed in deficit? This part of the earth, roughly 30 degrees north to 30 degrees south, is said to be beneficiary of higher insolation. Howda? And hence we call this region to be the tropical region. Howdalva? Tropical latitudes. Right? Beyond the tropical latitudes is what we get the subtropical and temperate latitudes. What happens to the amount of insolation in 30 to 60? Will it decrease or will it increase? Okay. And 60 to 90? The least anta helboda. Howdalva? Yes. So we call them to be the polar latitudes, which are very, very, very cold. Howdalva? Polar latitude, tropical latitude, subtropical latitudes, madhyadalli temperate areas antanu ಹೇಳ್ತೀವಿ. All right. And why is this phenomena experienced? Why is this phenomena experienced is because Earth is under the influence of two types of motions. Which are they? Rotation and revolution, isn't it? And I hope so you know about the basics of rotation and revolution. So quickly let me take you through this. If you can help me out with the axis of the earth. Is the axis of the earth perfectly perpendicular to its orbital plane that the earth revolves around? It's tilted. Okay. How is it tilted? Sure. So the equator is something like this, isn't it? Normally, it should have been this way, correct? Howdalva? And this way. So there is an angle 66.5 and 23.5. That is no complementary angles anta helತೀವಿ 90 degrees totally. Okay. This is the actual equator. The point where this interacts is going to be 23.5 north in the northern hemisphere. The point where this imaginary axis interacts is going to be north. Same is the case in the southern hemisphere. 23.5 south, 66.5 degree south. Is this the position of the earth? So earth is revolving around the sun in this alignment. True. So let us place sun somewhere over here. Though sun is nowhere comparable to the size of the earth, but because of our limitations, we'll have to adjust accordingly. So let me draw another. Earth with the same alignment. Obviously, will the alignment change? No. How will the alignment change? It will not change. It's just the position that is changing. Alignment will remain the same. 0 degree, 90 degree north, 90 degree south, 23.5 north, 66.5, south, 23.5 north, 66.5 north. Okay, na? So these are two different positions of the sun. When the sun is in its revolution in an elliptical orbit anta helteve, correct alva? So this is the elliptical orbit, right? At least somewhat similar. Now let us consider this to be 21st of June because it happens on 21st of June. Solar solstice. Do you know about 21st of June? Is there anything special about 21st of June? Longest day, very true. Yoga day, very true. Howdalva? 21st June ಗೆ ನಾವು ಇಂಟರ್ನ್ಯಾಷನಲ್ ಯೋಗ ಡೇ ಅಂತ ಸೆಲೆಬ್ರೇಟ್ ಮಾಡ್ತೀವಿ. ಯಾಕಂದ್ರೆ on that day we receive the maximum energy. That's the logic. Random again select ಮಾಡಿಲ್ಲ. 21st June ಗೆ the amount of energy that is incident in our region, tropical region, is the highest. Correct alva? Right? So whatever might be the case, bidi. The point is, on 21st June, this will actually be the position of the earth. The earth's north would be tilted towards the sun. The north is closer to the sun. Howdalva? Are we in the northern hemisphere? Are we in the north or in the south? Are we in the north or are we in the south? Nive? North alva? I mean, I thought you were dreaming. You were thinking about something else. 5 ಗಂಟೆಗೆ ಎಲ್ಲಿ ಹೋಗ್ಲಿ ನಾನು? ಯಾವಾಗ ಬಿಡ್ತಾನೆ ಇವನು? ಏನೇನೋ ಹೇಳ್ತಾ ಇದ್ದಾನೆ, ನನ್ಗೆ ಗೊತ್ತಿದೆ ಎಲ್ಲ ಹೇಳ್ತಾವನೆ. 5 ಗಂಟೆಗೆ ರಿಸರ್ವೇಶನ್ ಅಲ್ಲಿ ಮಾಡ್ಬೇಕಿತ್ತು ಇವತ್ತು. Okay, then miscommunication. Do you have any plans? Were you thinking about something else? It's okay, I don't mind. Okay, you're thinking about earth rotating. Nodi, yes, how noble souls do we have inside the classroom? We are thinking about the earth, nature, Mother Earth. All right. So at this point, 21st of June, where do you think the maximum, let's put it in a very dramatic way. Let's use colors. Hot rays means red color. So Earth's sun does not discriminate like humans. So it radiates everywhere equally. Howdalva? So where do you think, which hemisphere is receiving higher amounts of insolation on 21st of June? Pakka? If you are wondering about only this part of the earth receiving energy, you are forgetting that earth is also under rotation. So this part completely, when it rotates, this entire hemisphere is receiving maximum amount of insolation. With southern hemisphere, most of the areas do not even receive any amount of insolation. So can I say it is summers for the north? Pakka? northern hemisphere ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇನ್ಸೋಲೇಷನ್ ಜಾಸ್ತಿ ಟೆಂಪರೇಚರ್ ಇದ್ರೆ ಸಮ್ಮರ್ಸ್ ಅಲ್ವಾ ಅದು. ವಿಚ್ ಮಂತ್? ಜೂನ್ ಅಲ್ಲಿ ಪೀಕ್. ದಿಸ್ ಇಸ್ ದ ಪೀಕ್ ಆಕ್ಚುಲಿ. ಲೆಟ್ಸ್ ಟ್ರಾವೆಲ್ ಫರ್ದರ್. Let's say earth is here. I don't want the tilting and whatnot. It takes, how many days does it take for entire one single revolution? Sure. How many months? 12 months. 1 year has 12 months. If I divide it by 4, 360 by bada, 12 by 4, 3 plus 3 months. If this is June, direct conclusion beda, evolve madana. July, August, September, 22nd or 23rd. ಯಾವ ಸೀಸನ್ ಅಂತ ಗೊತ್ತಿಲ್ಲ, but the sun rays will be directly on equator when the earth is over here. I cannot show that. You have to imagine. That is what we call it as an equinox. Correct, Alva? What do you mean by an equinox? The duration of the day and the duration of the night are equal. In this case, what is the duration of the daytime? In north, whatever I say, it is in northern hemisphere. The northern hemisphere will have longer day. Do we have a longer day right now? Howda? Do we have a longer day right now? The duration of the daytime is longer, or duration of the night time is longer right now. February, March banbidito. Night time is longer. Huh? Correct alva? Okay, anyways. Let's move to this position. Plus 3 months. Howdalva? 6 months aadmelene il barodu. Correct alva? Now can I say entire the situation reverses? Howda? Where is the majority of the insolation incident on? Southern hemisphere, correct? And the northern hemisphere has diffuse amount of insolation, correct alva? Where is the summer now? In the southern hemisphere. Which month? September ಆದ್ಮೇಲೆ, October ಆದ್ಮೇಲೆ, November ಆದ್ಮೇಲೆ, 22nd December again. 22nd December is the shortest day in the northern hemisphere. Longest day for the southern hemisphere. How the Christmas celebrate ಮಾಡ್ತೀವಿ ನಾವು 25th December ಗೆ. Will it be cold? That means it is winter for us. Who are we? People of northern hemisphere. People of southern hemisphere will experience, people of Australia will have a hot Christmas. True or false? Akka? 3 months again. 23rd March, 22nd March, whatever. What is this? Equinox ಅಂತ ಹೇಳಿದ್ರೆ ಸಾಕು. Spring, autumn ಆಮೇಲೆ add ಮಾಡೋಣ. Duration of the day and duration of the night equal. Again, that means the insolation, the sun rays are directly vertical over equator. Correct alva? Illi 3 months down the line, where are we back again? March ಆದ್ಮೇಲೆ, April ಆದ್ಮೇಲೆ, May ಆದ್ಮೇಲೆ. These are the 4 seasons. Summer, autumn, correct alva? Winter, spring, again back. Correct alva? So tropical latitudes very, very, very evidently will experience seasons. Howda? Naturally, Karnataka will also experience the same thing. Okay, na? Can I conclude from this diagram that lower latitudes will always, lower latitudes andre equator akkapakadalli iruvanta ಒಂದು latitudes will have that quite great diversity. They will experience higher amount of insolation always anta helboda. Throughout the year they will experience higher amount of insolation helboda. Here also, illi equator alli direct insolation ಆಗ್ತಾ ಇರೋದು. Illi southern hemisphere alli in the tropical region. So tropical region always is hot. ನೋಡಿ 0 to 30 or 30 north or 23 north to 23 south. ಈ ಜಾಗಗಳಲ್ಲಿ insolation is always there. Even here. Insolation ಅಂದ್ರೆ direct insolation. There is a difference. Nodi, there is a difference between if this is the wall or this is the floor. Direct ray and slanting ray ವ್ಯತ್ಯಾಸ ಇದೆ. Will the direct ray get more energy or the slanting ray? Huh? Sure. Yake? How do you know this? How do you know this? ಚಿಕ್ಕ ವಯಸ್ಸಲ್ಲಿ ಕರೆಂಟ್ ಹೋದಾಗ ಟಾರ್ಚ್ ಅಲ್ಲಿ ಆಟ ಆಡ್ತೀವಿ. ಆಡಿದ್ದೀರಾ? ಟಾರ್ಚ್ ಮನೇಲಿ ಇಟ್ಟಿರ್ತಾರೆ, ಎಲ್ಲಾದ್ರೂ ಏನಾದ್ರು ತಗೊಂಬ ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ, ವಾಲ್ ಮೇಲೆ ಪ್ಯಾಟರ್ನ್ಸ್ ಮಾಡ್ತೀವಿ. ಹೌದಾ? ಮಾಡಿದೀರಾ? ಸೊ ಎವ್ರಿ ಚೈಲ್ಡ್ಹುಡ್ ಇಸ್ ದ ಸೇಮ್, ಆಲ್ಮೋಸ್ಟ್ ಮೋರ್ ಲೆಸ್, ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್. ಗುಡ್ ಥಿಂಗ್ ಬಿಡಿ. ಆ ಟಾರ್ಚ್ ಅಲ್ಲಿ ಆಟ ಆಡ್ತಿರುವಾಗ ಇಫ್ ಯು ಟೇಕ್ ದ ಟಾರ್ಚ್ ಕ್ಲೋಸರ್ ಟು ದ ವಾಲ್, ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್? ದ ಇಮೇಜ್ ವಿಲ್ ಬಿ ಸ್ಮಾಲರ್. ದೂರ ಹೋಗ್ತಾ ಹೋಗ್ತಾ ಇದೆಲ್ಲ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರುತ್ತಲ್ವಾ ನೋಡಿ, ಬಿಕಾಸ್ ಯು ಯೋರ್ ಸೆಲ್ಫ್ ಹ್ಯಾವ್ ಪ್ರಾಕ್ಟಿಕಲಿ ಡನ್ ಇಟ್, ಸೊ ಯು ರಿಮೆಂಬರ್ ಇಟ್. ಮೇ ಬಿ ದೂರ ಹೋಗ್ತಾ ಹೋಗ್ತಾ, okay. And also try to imagine if you have not done it, if you are if the light is incident on the wall in a pretty straight beam, what will be the pattern? A perfect circle. If you tilt it, the circle will get disturbed. Probably it will be an oval shape or something much bigger. Howda? What is the output of the torch? Is it same or is it variable? Output of the torch is emitting constant light. ಈಗ ಟಾರ್ಚ್ ಅಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಮೋಡ್ಸ್ ಇದೆ, ಹೈಯರ್ ಪವರ್ ಮೋಡ್, ಲೋವರ್ ಪವರ್. ನೋ, ಐ ಆಮ್ ಕನ್ಸಿಡರಿಂಗ್ ಅ ಟಾರ್ಚ್ ದಟ್ ಡಸ್ ನಾಟ್ ಹ್ಯಾವ್ ಎನಿ ಚೇಂಜಸ್, ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ಟಾರ್ಚ್ ಲೈಕ್ ಸನ್. ಡಸ್ ಸನ್ ಹ್ಯಾವ್ ಎನಿ ಮೋಡ್ಸ್? ಇವತ್ತು ಮೂಡ್ ಚೆನ್ನಾಗಿಲ್ಲ, ಲೆಟ್ಸ್ ಬರ್ನ್ ಎವ್ರಿ ಒನ್ ಅಂತ ಏನಾದ್ರು ಆತರ ಇಲ್ಲಲ್ವಾ? ಸೊ ಅ ಟಾರ್ಚ್, the torch has a constant output, correct alva? And the pattern that you get, if the pattern is smaller, can I say more energy per unit area? Howda? More energy per unit area. And if you go away, the pattern becomes bigger, same output spread over large distances, less energy per unit area, correct? Ade kate idardu. Direct ag bandre, whatever the incident energy in a small area ತುಂಬಾ ಇಂಟೆನ್ಸ್ ಆಗಿರುತ್ತೆ. ಇಫ್ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಇನ್ ಅ ಸ್ಲಾಂಟ್ ವೇ, ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್? ದ ಎನರ್ಜಿ ವಿಲ್ ಸ್ಪ್ರೆಡ್ ಓವರ್ ಲಾರ್ಜ್ ಡಿಸ್ಟೆನ್ಸಸ್, ಪರ್ ಯೂನಿಟ್ ಎನರ್ಜಿ ತುಂಬಾ ಕಮ್ಮಿಯಾಗಿ ಸಿಗುತ್ತೆ. ದಟ್ ಇಸ್ ದ ಕೇಸ್. ಲೋವರ್ ಲ್ಯಾಟಿಟ್ಯೂಡ್ಸ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಡೈರೆಕ್ಟ್ ರೇಸ್, ಅಪ್ಪರ್ ಲ್ಯಾಟಿಟ್ಯೂಡ್ಸ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಸ್ಲಾಂಟಿಂಗ್ ರೇಸ್. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಸೊ ದಟ್ಸ್ ವೈ ದೇ ಆರ್ ಕೋಲ್ಡ್. Are you understanding this? It's not like they do not receive insolation. They will receive insolation, but the insolation what they receive is a slanting ray. ಸೊ ಏನ್ ಎನರ್ಜಿ ಬರುತ್ತೆ ನಮಗೆ ಒಂದ್ ರೇ ಅನ್ನ ತಗೊಂಡ್ರೆ, ಇಲ್ಲಿ ಬೆಂಗಳೂರಲ್ಲಿ ಒಂದ್ ರೇ ಪೋಲಾರ್ ರೀಜನ್ ಅಲ್ಲಿ, ದ ಡಿಫರೆನ್ಸ್ ಇನ್ ಎನರ್ಜಿ ರಿಸೀವ್ಡ್ ವಿಲ್ ಬಿ ಮ್ಯಾಸಿವ್ ಡಿಫರೆನ್ಸ್, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಸೊ ಕೋಲ್ಡ್ ರೀಜನ್ಸ್ ಆರ್ ಇನ್ ದ ಅಪರ್ ಲ್ಯಾಟಿಟ್ಯೂಡ್ಸ್ ಇಸ್ ಅ ಬೆನಿಫಿಷರಿ ಆಫ್ ಸ್ಲಾಂಟಿಂಗ್ ರೇಸ್. ವಿ ಇನ್ ದ ಟ್ರಾಪಿಕಲ್ ರೀಜನ್ ಇಸ್ ಅ ಬೆನಿಫಿಷರಿ ಆಫ್ ಡೈರೆಕ್ಟ್ ಸನ್ ರೇಸ್, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಎಲಿಮೆಂಟ್ ಆಫ್ ಡೌಟ್, ನಾಳೆ 3 ಗಂಟೆಗೆ ಅಥವಾ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಆಗೋದು ಯಾವಾಗ? 2 ಗಂಟೆಗೆ ಅಲ್ವಾ? 1:55 ಹೊರಗಡೆ ಒಂದು 5 ನಿಮಿಷ ನಿಂತ್ಕೊಂಡ್ಬಿಡಿ, ಒಂದು 5 ನಿಮಿಷ ನಿಂತ್ಕೊಂಡ್ಬಿಡಿ. ಇದು ಸಮ್ಮರ್ ಅಲ್ಲ ಆಕ್ಚುಲಿ. ಇಮ್ಯಾಜಿನ್ ಸಮ್ಮರ್ ಅಲ್ಲಿ ಒಂದು 5 ನಿಮಿಷ ನಿಂತ್ಕೊಂಡ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ? ಟ್ಯಾನ್ ಆಗ್ಬಿಡ್ತೀವ? ಅದ್ ಮಾತ್ರ ಟ್ಯಾನ್ ಆಗ್ಬಿಡ್ತೀವಲ್ವಾ? ಎಸ್, ಮತ್ತೆ ಡಿಟ್ಯಾನ್ ಮಾಡಿಸ್ಬೇಕು. ಸೊ ಡೋಂಟ್ ಡೂ ದಟ್. ಅದೇ ನೀವು ಪೋಲ್ಸ್ ಅಲ್ಲಿ ಹೋದ್ರೆ ಅಥವಾ 60 ಡಿಗ್ರಿ ಲ್ಯಾಟಿಟ್ಯೂಡ್ ಅಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು 5 ನಿಮಿಷ, ಇಫ್ ಯು ಸ್ಟ್ಯಾಂಡ್ ಇನ್ ದ ಸನ್, ಡು ಯು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಯುವರ್ ಸೆಲ್ಫ್ ಟು ಬಿ ಟ್ಯಾನ್? ಫಾರಿನರ್ಸ್ ನೋಡಿ ಅಲ್ಲಿಂದ ಇಲ್ಲಿ ಬರ್ತಾರೆ ಟ್ಯಾನ್ ಆಗಕ್ಕೆ, ಹೌದಲ್ವಾ? ಗೋವಾಗೆ ಹೋಗಿದ್ದೀರಲ್ವಾ ನೀವು? ಗೊತ್ತಿಲ್ವಾ ಇವೆಲ್ಲ ನಿಮಗೆ? ಗೊತ್ತಿದೆಯಲ್ವಾ? ಹೇಳಿ ಎಲ್ರಿಗೆ. ಹೋಗಿಲ್ಲ ಅಂತೆ ಅವರೆಲ್ಲ ಸುಮ್ನೆ ಹೋಗ್ತಾರಲ್ವಾ, ದೇ ಕಮ್ ಬೀಚ್ ಅಲ್ಲಿ ಮಲ್ಗ್ಬಿಟ್ಟಿರ್ತಾರೆ, 5-10 ನಿಮಿಷ ಇರಕ್ ಆಗಲ್ಲ ಅದರಿದ್ರ ಬೀಚ್ ಅಲ್ಲಿ ಗೋವಾದಲ್ಲಿ. ಹಂಗ್ ಬಿಸಿಲು ಹೊಡಿತಾ ಇರುತ್ತೆ, ಅವ್ರೆಲ್ಲ ಮಲ್ಗಿರ್ತಾರೆ ಟು ಗೆಟ್ ಟ್ಯಾನ್. ಯಾಕಂದ್ರೆ ಅವ್ರವ್ರ ದೇಶಗಳಲ್ಲಿ 24 ಗಂಟೆ, ಇಫ್ ಯು 12 ಗಂಟೆ ಏನೋ ಸನ್ ಬರುತ್ತೆ, ಹೊರಗಡೆ ಬಿದ್ದರೂ ಟ್ಯಾನ್ ಆಗಲ್ಲ. ದಟ್ ಇಸ್ ಪರ್ ಯೂನಿಟ್ ಎನರ್ಜಿ ರಿಸೀವ್ಡ್ ಇಸ್ ವೆರಿ ಡಿಫ್ಯೂಸ್ಡ್, ಲೆಸ್. ಓಕೆನಾ? ಸೊ ದಟ್ ಈಸ್ ಒನ್ ಥಿಂಗ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಸೆಕೆಂಡ್, ಲೆಟ್ಸ್ ಟಾಕ್ ಅಬೌಟ್ ಅಟ್ಮಾಸ್ಫೆರಿಕ್ ಪ್ರೆಷರ್. ಎಕ್ಸಾಮ್ ಆದ್ಮೇಲೆ ಹೋಗಿ ಗೋವಾ. ಎಕ್ಸಾಮ್ ಚೆನ್ನಾಗೈತಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಡೇ ಗೋವಾ ಹೋಗ್ತೀನಿ ಅಂತ ಪ್ರಾಮಿಸ್ ಹಾಕೊಂಡ್ಬಿಡಿ. ಏನ್ ಸರ್, ನಿಮ್ಗೆ ಹತ್ರ ಅಲ್ವಾ? ಸೊ ಪ್ಲಾನಿಂಗ್ ಆಮೇಲೆ ಮಾಡೋಣ. ಲೆಟ್ಸ್ ಟಾಕ್ ಅಬೌಟ್ ಅಟ್ಮಾಸ್ಫೆರಿಕ್ ಪ್ರೆಷರ್. ಸೊ ಬೇಸಿಕ್ ಡೆಫಿನೇಷನ್ ಏನು? ವೇಟ್ exerted by a unit, weight exerted by a unit air column Nodi, let this be the surface of the earth. Sir, your name for the class. Sir, you know? Yeah, Abhishek. Let's consider Abhishek here, standing, doing nothing. Andre, just for doing nothing, Andre, or ಏನೇನೋ ಅನ್ಕೊಳ್ತಾ ಇದ್ದಾರೆ. Okay. Can I say Abhishek is under the influence of different constituents of the atmosphere, that is, different gases of the atmosphere? How the? Our atmosphere extends from the mean sea level to approximately 800 kilometers and beyond ಅಂತಾನು ಹೇಳ್ತಾರೆ. Diffuse ಆಗಿರುತ್ತೆ. But yes, we have some elements of gases still there ಅಂತ ಹೇಳ್ತೀವಿ. ಹೌದಾ? Now ನೋಡಿ, if I take a unit column of air, probably 1 centimeter cube or 1 meter cube or whatever might be the unit, a square, and if I add a pipe right from the top of Abhishek's head till the end of the atmosphere, let me trap that gases in that pipe. Can I measure the weight of that pipe? Pipe alla, pipe ಅಲ್ಲಿ ಒಳಗಡೆ ಇರುತ್ತಂತ gases ಅನ್ನ weight ಅನ್ನ measure ಮಾಡಬಹುದಾ? That is ಏನದು? That weight exerted by this unit column of air is what we call it as 1 atmosphere. 1 atmosphere anta kariತೀವಿ. If you want to know the number, the value, somewhere around 1013.25 millibars. Millibars al measure ಮಾಡ್ತೀವಿ. This is something what we call it as the atmospheric pressure. Now this pressure can be low and can be higher depending upon what is the constituent of the atmosphere right over there. If there are too much of gases, let us say excess gases, if the winds are pushing too many gases, will Abhishek feel a heavy atmospheric pressure over him? Yes, such a condition would be called as a high pressure conditions. Correct, Alva? If for whatever reason, if the winds move away from the top of Abhishek, Abhishek will experience less weight of the atmosphere. So that pressure condition would what we call it as low pressure. Correct, Alva? Now this is what we utilize. This mechanism is what we utilize to understand the winds, right? Combining atmospheric pressure and atmospheric temperature. If I combine these two variables, I can arrive at the patterns of wind movements. Let us consider the latitudes of the earth. 0 degree, 30 degree, 60 north, 30 south, 60 south, and 90 south. This is the latitudinal, right, profile of the earth, right? I've taken in a horizontal, in a two-dimensional way. Okay, now at the equator, what is the overall temperature conditions throughout the year? There is not one single day over equator where there is no direct sun ray. Andre throughout the year, hot conditions. If there is too much of heat, excess of heat in a particular region, what should be the pressure conditions that you can experience? Yake? Why low pressure? Sir, what happens? What happens? Explain me the theory. Once you understand the theory, you'll never forget it. If I heat this object, what happens to this object? It will melt and bada. If I gradually heat this object, what will happen to this object? It will expand. Are you understanding this? What happens to the volume of this object? Or in general, what happens to the volume, whatever might be the state of the matter, solid, liquid, gas? If I heat that particular component, what happens to the volume? Volume will increase or decrease? Confident ಆಗಿ volume will increase. If the size increases, volume increases. Pakkana? If I heat a particular object, what happens to its volume? Increases. Sure. If I cool a particular object, it will contract. Volume decreases. Howdalva? Right? What is the relationship between volume and density? Volume and density. Inversely proportional. ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಡೆನ್ಸಿಟಿ ಕಮ್ಮಿ ಆಗುತ್ತೆ. Equatorial region ಅಲ್ಲಿ temperature ಜಾಸ್ತಿ. What will happen to the volume of the air? Increases. So that means the same parcel of air is now spread over large distances. Per unit weight exerted will be high or low. Per unit weight exerted will be high or low. Same volume, now it is spread, dispersed because of the heat. Heat has expanded the system. ಅದೇ equatorial ನಿಂತ್ಕೊಬಿಟ್ಟು ನಾನು ನೋಡ್ತಾ ಇದ್ದೀನಿ. Now the heat, because of the heat, the components of the air, the composition of the atmosphere has dispersed. Will I experience more weight or less weight now? Less weight means what pressure? What is the pressure always over the equator? Low pressure. Very easy this is. Poles only. Will it be opposite? Cold, very cold conditions. Contract. ಅಕ್ಕಪಕ್ಕದಲ್ಲಿ ಇರುವಂತಹ ಒಂದು ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಗ್ಯಾಸಸ್ ಅನ್ನ ಕಾಂಟ್ರಾಕ್ಟ್ ತಗೊಂಡ್ಬಂದ್ಬಿಟ್ಟು ಇನ್ ಅ ವೆರಿ ಸ್ಮಾಲ್ ಪಾರ್ಸಲ್ ಆಫ್ ಲ್ಯಾಂಡ್ ಮಾಸ್ ದ ವೇಟ್ ಎಕ್ಸರ್ಟೆಡ್ ವಿಲ್ ಬಿ ಹೈ ಅಂತ ಹೇಳ್ಬೋದಾ? ಹೈ ವೇಟ್ ಅಂದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಪ್ರೆಷರ್? ಆಲ್ವೇಸ್ ಪ್ರೆಷರ್ ವಿಲ್ ಬಿ ಹೈ ಇನ್ ಬೋತ್ ದ ಪೋಲ್ಸ್. ಹೌದಾ? ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಎಸ್ ಆರ್ ನೋ? Another relationship that we know about. Wind always moves from a region of. Madam, if a pressure is low, what can I conclude? This region will receive air mass. Howda? Pakkana? Pressure is always relative ನೋಡಿ. ನೀವು ಹೋಗ್ಬಿಟ್ಟು ಇಲ್ಲಿ ಹೊರಗಡೆ ಇರುವಂತ ಪ್ರೆಷರ್ ಹೈ ಅಥವಾ ಲೋ ಹೇಳಕ್ ಆಗಲ್ಲ. ನೀವು ಒಂದು ನಂಬರ್ ಕೊಡಕ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ. But if I ask you to compare the pressure of Vijayanagara with that of somewhere else, Hebbala, you can give, okay, the pressure over is high or low ಅಂತ ಒಂದು relative dimension ಅದು ಅಷ್ಟೇ. ಅಥವಾ pressure is just a number. So in comparison, nodi, if I say if a region has a low pressure, madam, will it receive winds or should it give out winds? Low pressure region will always, because it is deprived of the gases. Howdalva? If it is low pressure, always remember winds will flow towards it. If it is high pressure, what will happen to it? Should it receive winds or should it give out winds? High pressure in the always ಹೊರಗಡೆ ಬರುತ್ತೆ. Correct ಅಲ್ವಾ? ಹೌದಲ್ವಾ? So if a latitude over here, 60-degree latitude, is receiving winds, what pressure? Sure. ಅಷ್ಟೇ. If it is receiving winds, low pressure. If this latitude is sending out winds, ಅಷ್ಟೇ. You can now fill it. This is the theoretical explanation. ಇದು ನೆನ್ಪಿಟ್ಕೊಳಕ್ ಆಗಲ್ಲ. ಲ್ಯಾಟಿಟ್ಯೂಡ್ನಲ್ ಪ್ರೆಷರ್ ಪ್ರೊಫೈಲ್ ಆಫ್ ದಿ ಅರ್ತ್ ಅಂದ್ರೆ ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ಆಲ್ಟರ್ನೇಟ್ ಹೈ ಲೋ ಹೈ ಲೋ ಹೈ ಲೋ ಹೈ. ಇಷ್ಟಾದ್ರೂ ನೆನ್ಪಿಟ್ಕೊಳಕ್ ಆಗುತ್ತಲ್ವಾ? ಮೈ ಜಾಬ್ ಇಸ್ ಟು ಗಿವ್ ಯು ದ ಥಿಯರಿ ಅಂಡ್ ವೇ ಟು ರಿಮೆಂಬರ್ ಇಟ್ ಆಲ್ಸೋ. So winds always move from a region of high pressure to low pressure. But is this how in reality it is happening? No. There are other influences also. What are the other influence? Westerly, easterly ಆಗುತ್ತೆ. Have you ever heard about Coriolis deflection? ಅದೇನು? Coriolis deflection ಅಂದ್ರೆ ಏನು? Rotation of the earth. ಏನದು? Earth rotate ಆದಾಗ wind will deviate. Okay. In what directions will it deviate? Northern hemisphere ಅಲ್ಲಿ right deviation ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀರಾ. Okay. 5 minutes I'll take it to explain this. ನೋಡಿ. Earth is under a rotation. We will try to simulate it in some other way. ನಮಗೆ ಸ್ಟಡೀಸ್ ಈಗ ಓದಿ ಥಿಯರಿ ಹಿಂಗ್ ಓದಿ ಅಂದ್ರೆ ನಮ್ಮ ಮೈಂಡ್ ಎಕ್ಸೆಪ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಲ್ಲ. Analogy is the best way to study. Let us imagine we are sitting on a rotating floor. The floor that you are sitting, this floor is rotating in the same direction as that of the earth, west to east. Okay. Can you imagine that you are on a rotating floor? There will be a center for this rotating floor. There will be a periphery. Probably, sir, or the benches over here, which is very closer to me is the periphery, and the last benches are the periphery, and people who are sitting in between are in the center. How the? So you are rotating in a particular direction. I am not in that floor. I am outside. I am an external object over here. I am an external observer over here who's standing and wanting to see how do you react to the rotation. Okay, na? And the switch is what I have it. ನನ್ನ ಹತ್ರನೇ ಇದೆ. The direction, the pace in which I have to make you, the angular velocity with which you are rotating, I can control it. And I'm increasing the velocity. You are rotating at a massive speed ಅನ್ಕೊಂಡ್ಬಿಡೋಣ. Correct ಅಲ್ವಾ? Will you want me to stop? You cannot bear it for some time. Correct ಅಲ್ವಾ? And what will you do? You'll ask me to stop. I am not going to stop. You have to rotate over there ಅಂತಾನೆ ಹೇಳ್ತೀನಿ. ಏನ್ ಮಾಡ್ತೀರಾ? ಇವನು ತುಂಬಾ ಕ್ವೆಶ್ಚನ್ಸ್ ಕೇಳ್ತಾನೆ. ಪ್ಲಸ್ ನಮಗೆ ಟಾರ್ಚರ್ ಕೊಡ್ತಾ ಇದ್ದಾನೆ. ಟಾರ್ಚರ್ ಹೆಲ್, ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಹೆಲ್ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ. ಸೊ ಏನ್ ಮಾಡೋಣ, ಇನ್ ಸ್ಟಾಪು ಮಾಡ್ತಾ ಇಲ್ಲ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಸರ್ ಏನ್ ಮಾಡ್ತಾರೆ, ಗೋವಾಗ್ ಹೋಗ್ತೇನೆ ಅಂತ ಅವ್ರು ಕೇಳ್ತಾನೆ ನನಗೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಅವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ, ಅವ್ರ ಹತ್ರ ಇರೋದನ್ನ ಬಾಟಲ್ ತಗೊಂಡು ನನ್ನ ಕಡೆ ಬಿಸಾಕ್ತಾರೆ. ವೈಲ್ ಹೀಸ್ ಅಂಡರ್ ರೊಟೇಷನ್. ಸರ್ ಬಾಟಲ್ ತಗೊಂಡ್ಬಿಟ್ರು, ಯಾಕೋ ಗೊತ್ತಿಲ್ಲ ಸರ್. ಜಸ್ಟ್ ಕಿಡಿಂಗ್. ವಾಟ್ ಎವರ್ ಯು ಹ್ಯಾವ್, ಫೋನ್ಸ್ ಬಿಸಾಕ್ಬೋದು. ಕ್ಯಾಚ್, ಐ ವಿಲ್ ಕ್ಯಾಚ್ ಇಟ್. I don't know if I can catch it, but ನೋಡಿ, if you are rotating at a very fast pace, angular velocity ತುಂಬಾ high ಆಗಿರುತ್ತೆ, and I am standing over here and you know I am the culprit and you have to aim at me, what will you do? If you have to throw, successfully hit, what will you do? Can you aim at me properly and hit? What happens if you aim at me? What happens if you aim at me directly? For me, who is an external observer, if you are rotating in this anti-clockwise direction, where will the object land? Sir, ನೀವು ನಿಮ್ಮ ಫೋನ್ ತಗೊಂಡ್ಬಿಟ್ಟು you pointed out, you aimed at me and you have thrown it. Is that body also in inertia along with you? Where will it land? To my right, to the right of an external observer. Ashte logical. I'm not going to extend this any further. Correct alva? To the people of the northern hemisphere, a free flowing object capable of traveling large distances will appear to be deflecting towards right. And to the people, if I can completely turn this floor upside down, imagine you are sticking to the floor here and the floor is rotating. The same thing, now if you throw, it will appear as if you are the object is deflecting towards my left. Ashte logic, correlate force. It is due to rotation. What I told you, the rotating floor, I have comparing this with the rotation of the earth. That object, what you are throwing, is a free-flowing object capable of traveling multiple latitudes. Artha agta idya? Deflection will be towards right. So all the winds that are moving in the northern hemisphere will undergo deflection towards their right. Correct alva? So please, if you can tell me the directions. If you can help me out with directions. Nodi, directions hege? North, south, east, west. Correct alva? If a wind is originating and traveling in this direction, what will you call this wind? Monsoon beda. South west anta kariyana saku. Hauda? Let us say a wind, a fan, a massive powerful fan. I have it. I have crazy things alva. Nodi, imagination alli. Right? A massive powerful fan ide ನನ್ನ ಹತ್ರ, and I'm switching it on. The wind that it is going to emit, you know the source of it. Where is the source of it? That fan. But can you tell me where is it going to end? Where is the wind particle going to land finally? ಹೇಳ್ಬೋದಾ? Yes. ಎಲ್ಲಿ? If I install that fan over here and I throw it in this side, in this direction, where is that wind molecule particle going to end? Final point ಎಲ್ಲಿರುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದಾ? ಎಲ್ಲಿರುತ್ತೆ? This wall, there is no wall. Let us say there is no wall. It will continues to move. Where will it end? ಹೇಳಕ್ಕಾಗಲ್ಲ. That's my point. But can I say where it has started for sure? ಹೇಳ್ಬೋದಾ? That's as simple as that. Winds are always named after the point of origin. If this is the direction of the wind, this wind would be called as southwesterly. Ashte logic. If the wind is in this direction, what would you call this wind to be? Northwesterly. Okay, na? All right. In the northern hemisphere, deflection towards the right, Andre, what should be the direction? Direction heli. Let me give you some options. Just match the following. This is southwesterly, northeasterly. ಇಷ್ಟೇ ಬೇಕಾಗಿರೋದು. Right deflection means which among these? Is this right for this? Correct alva? Andre you have to face towards the arrow and then decide. If I'm facing, this is arrow is facing down, andre arrow is facing the wall behind, and now this is the right, so I have added that right deflection. Here it's going to be this way, southwesterly, correct alva? And it is going to be the same over here. For the southern hemisphere, left deflection, correct alva? Left deflection. Is this left deflection? Haudalva, facing the arrow. If I'm facing the arrow, this is my left, correct alva? Now I'm facing the arrow. My left would be this side. Am I right? Howda? Can you name, madam, can you name the winds here? What shall I call these winds? Madam? Northeasterlies, arising from the east. Northeasterlies. This southwesterlies, northeasterlies. Confuse aguttಲ್ವಾ ಇವೆರಡು ಸೇಮ್ ಅಲ್ವಾ? ಬೇರೆ ಹೆಸರು ಕೊಡೋಣ ಬೇಡವಾ? ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತಲ್ವಾ? ಇಫ್ ಐ ಸೇ ನಾರ್ತ್ ಈಸ್ಟರ್ಲೀಸ್ ವಿಚ್ ವುಡ್ ಯು ಸರ್ಚ್ ಫಾರ್? ಬೇರೆ ಹೆಸರು ಕೊಡೋಣ. ಇದನ್ನ ಪೋಲಾರ್ ವಿಂಡ್ಸ್ ಅಂತ ಕರೆಯೋಣ, ಓಕೆನಾ? ಇದನ್ನ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಅಂತ ಕರೆಯೋಣ. ಯಾಕಂದ್ರೆ ದ ಶಿಪ್ಸ್ ಅರ್ಲಿಯರ್ ಟ್ರೇಡಿಂಗ್ ಶಿಪ್ಸ್ ಯೂಸ್ ಟು ಡಿಪೆಂಡ್ ಆನ್ ವಿಂಡ್ಸ್ ಅಲ್ವಾ, ಟು ಸೇಲ್ ಥ್ರೂ. ಅದಕ್ಕೋಸ್ಕರ ಇಲ್ಲಿ ಈ ಲ್ಯಾಟಿಟ್ಯೂಡ್ಸ್ ಅಲ್ಲಿ ಆಗ್ತಾ ಇತ್ತು. ಸೊ ಇದನ್ನ ಟ್ರೇಡ್ ವಿಂಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಇದನ್ನ ವೆಸ್ಟರ್ಲಿ ವಿಂಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ದಟ್ ಇಸ್ ಸೌತ್ ವೆಸ್ಟರ್ಲಿ. ಇದನ್ನ ಪೋಲಾರ್ ಈಸ್ಟರ್ಲೀಸ್ ಅಂತ ಕರಿತೀವಿ. ಅರ್ಥ ಆಯ್ತಾ? This will play a role, massive role it is going to play. Are you understanding this? Do you know all these basics? ಮರ್ತೋಗಿದ್ವಿ? ಮರ್ತೋಗಿಲ್ವಾ? Okay, very good. Then apart from this, atmospheric temperature, atmospheric pressure, seasons ಆಯ್ತು, you know the wind patterns. And what about the atmospheric moisture? Some basics of atmospheric moisture ಮುಗಿಸ್ಬಿಡೋಣ ಬೇಗ. Tomorrow, I mean, in the next class, we'll start with the climatology afresh. Atmospheric moisture. Atmospheric moisture is nothing but the amount of water vapor present in the air. How much water vapor is there in the atmosphere in totality is what we call it as atmospheric pressure. But if I have to compare it over a region, over a place, relevance to the term humidity comes into picture. Humidity is nothing but, humidity is defined to be the amount of water vapor present in a unit air column. Ist air column anta consider ಮಾಡ್ತೀವಿ, ಅದರಲ್ಲಿ ಎಷ್ಟು water vapor ಇದೆ, that is what we call it as atmospheric humidity. And what is that humidity that we use to measure? Which humidity? We use relative humidity. Relative humidity. Humidity ಎಷ್ಟು ಅಂತ ಇದು ಗೂಗಲ್ ಮ್ಯಾಪ್ಸ್ ಅಲ್ಲಿ, ಐ ಮೀನ್ ಗೂಗಲ್ ವೆದರ್ ರಿಪೋರ್ಟ್ ಅಲ್ಲಿ ತೋರಿಸುತ್ತಾ? How much is the humidity over Bangalore today ಅಂತ ನೋಡಿ, ಇವಾಗ ಎಷ್ಟಿದೆ ಅಂತ ನೋಡಿ. What is the unit? Unit ಬೇಕು, humidity ಬೇಡ. ಅದು ಹ್ಯೂಮಿಡಿಟಿನಾ? ಟೆಂಪರೇಚರ್ ಎಷ್ಟು? ಹ್ಯೂಮಿಡಿಟಿ 30 ವಾಟ್ ಪಕ್ಕಾ? ಯು ಹ್ಯಾವ್ ನಾಟ್ ಸೀನ್? ಪಕ್ಕಾನಾ 30%? ಐ ಡೋಂಟ್ ನೋ. ವಿಂಡ್ ಯಾಕೆ ನಮಗೆ? ಪಕ್ಕಾ ಮೇಡಮ್? ಓಕೆ, 30%, 26%. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಅರ್ಥ ಏನು? Whatever the air column, the volume of the air column is present around us right now, 30% of that is occupied by moisture ಅಷ್ಟೇ. If this moisture level increases, ಅದಂತೂ ಗೊತ್ತಿರುತ್ತೆ, 90%, 90%, 95%, 100% ಇದ್ರೆ ಏನ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತೀರಾ? ಅಲ್ಲಿ ಸಿಂಬಲ್ ಚೇಂಜ್ ಆಗ್ಬಿಡುತ್ತೆ, ಕ್ಲೌಡ್ ಸಿಂಬಲ್ ಬಂದ್ಬಿಡುತ್ತೆ, ಮಳೆ ಸಿಂಬಲ್ ಬಂದ್ಬಿಡುತ್ತೆ, ಹೌದಲ್ವಾ? That is what I'm going to tell you about this. Relative humidity is a term, or it's a measure of the humidity measured in percentage. Andre, ratio to what extent of the volume water vapor is occupying. Anta. Okay, na? I would like to discuss this also very quickly. Hydrological cycle. Are we aware about hydrological cycle? Yes. First step of hydrological cycle, you know. I believe ಚಿಕ್ಕ ವಯಸ್ಸಲ್ಲಿ ಇದೇ ಡಯಾಗ್ರಾಮ್ ಮಾಡಿರ್ತೀರಾ ಹಿಂಗೆ one line ದೊಡ್ಡದು one line ಚಿಕ್ಕದು one line ದೊಡ್ಡದು one line ಚಿಕ್ಕದು that means it is sun correct ಅಲ್ವಾ ಒಂದು ರೇ ಬರುತ್ತೆ ಇನ್ಸೋಲೇಷನ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ವಾಟರ್ ಇವಾಪರೇಟ್ ಆಗುತ್ತೆ ಈ ತರ ಗ್ಯಾಸ್ ತೋರಿಸ್ಬೇಕಲ್ವಾ ಕರೆಕ್ಟ್ ಅಲ್ವಾ gas is lighter what will happen to the gas being lighter it rises and when it rises what happens temperature what happens to the temperature when it rises yak decrease agbeku explanation water molecule increase when it's increasing its temperature sorry when it's increasing its altitude temperature will decrease yak decrease agbeku from where is the atmosphere getting heated from the bottom correct alwa the more you are away from the surface of the earth what will happen to the temperature that's the logic again over here and at one point we reach a temperature which we call it as dew point temperature that is when condensation happens correct alwa condensation is a process of reconversion of gas into either solid or liquid ice crystal form agbodu water droplet form agbodu once the base of this cloud becomes heavy what happens precipitation line straight irbeku this is you know right this is precipitation precipitation is based simply defined to be the fall of moisture aste this is the hydrological cycle correct alva right so what is required nodi if I ask you at this point let us say if the atmospheric if the humidity is 30% what should it be at this point higher or lower than 30% as it is increasing its in height what should happen to the proportion of the water vapor increase or decrease 50% 80% 100% correct alva 100% andre artha eno complete composes that part of the atmosphere is completely saturated by water vapor can you increase the proportion any further 100% ಗಿಂತ ಜಾಸ್ತಿ increase ಮಾಡಬಹುದಾ ಸುಮ್ಮನೆ ಹೇಳಕ್ ಹೇಳ್ತೀವಿ 110% ಈ ಕ್ವೆಶ್ಚನ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀವಿ there is nothing called as 110% 200% ಶೋರ್ ನಾನು ಅಂತೀನಿ 100% ಗಿಂತ ಜಾಸ್ತಿ ಆಗಕ್ ಸಾಧ್ಯನೇ ಇಲ್ಲ ಕರೆಕ್ಟ್ ಅಲ್ವಾ so anything that any cooling down beyond this 100% what will happen the air cannot hold that moisture it will throw it out that is condensation it cannot hold it anymore correct alva the capacity is reached it cannot hold it anymore so naturally it will throw it out in form of ice crystals or tiny water droplets that is what we perceive to be clouds accumulate aagta irutte and once it becomes very heavy what will happen that moisture will fall down I'm interested over here I did not wanted to revise this fourth standard hydrological cycle but what I wanted to do is I wanted to speak about this precipitation there are different types of precipitation kelidira since it applies to Karnataka I wanted to discuss this there are different types of precipitation convectional precipitation not conventional convectional precipitation convectional precipitation andre eno are you aware about the fact that horizontal movement of wind is called as what is horizontal movement of wind called as wind inneno ಏನು advection ಕೇಳಿದಿರಾ ಹಾರಿಜಾಂಟಲ್ ಮೂವ್ ಆದ್ರೆ ವಿಂಡೋ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಲ್ಲ ಇವೆಲ್ಲ ಜಸ್ಟ್ ಬುಕ್ಸ್ ಅಲ್ಲಿ ಲಿಟರೇಚರ್ ರಿಮೈನ್ ಇರುತ್ತೆ ಅದಕ್ಕೋಸ್ಕರ ವಿಂಡ್ ಹಾರಿಜಾಂಟಲಿ ಮೂವ್ ಆದ್ರೆ ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ advection ವರ್ಟಿಕಲ್ ಮೂವ್ ಆದ್ರೆ ಅದಕ್ಕೆ ಕನ್ವೆಕ್ಷನಲ್ ರೈನ್ಫಾಲ್ ಅಂತ ಹೇಳ್ತಿರೋದು ದಟ್ಸ್ ಮೈ ಪಾಯಿಂಟ್ ಓವರ್ ಹಿಯರ್ ಕನ್ವೆಕ್ಷನಲ್ ಪ್ರೆಸಿಪಿಟೇಷನ್, ಈಕ್ವೇಟರ್ ಅಲ್ಲಿ ತುಂಬಾ ಜಾಸ್ತಿ ಹೀಟ್ ಆಯ್ತು, ಇರೋ ಎಲ್ಲ ಮಾಯಿಶ್ಚರ್ ಏನಾಗುತ್ತೆ, ವಾಟರ್ ವೇಪರ್ ತುಂಬಾ ಲೈಟ್ ಆಗ್ಬಿಟ್ಟು ಇಟ್ ವಿಲ್ ರೈಸ್ ಅಂಡ್ ಎವ್ರಿ ಡೇ ರೈನ್ಫಾಲ್ ಇರುತ್ತೆ. ವಾಟ್ ಇಸ್ ದಿಸ್ ರೈನ್ಫಾಲ್ ಕಾಲ್ಡ್ ಅಸ್? 4 o'clock ಪ್ರೆಸಿಪಿಟೇಷನ್ ಕನ್ವೆಕ್ಷನಲ್ ಪ್ರೆಸಿಪಿಟೇಷನ್. ಪ್ರತಿ ದಿನ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ಏರ್ ಮಾಸ್ ರೈಸಸ್, ವರ್ಟಿಕಲ್ ಮೂವ್ಮೆಂಟ್ ಇಂದ ಆಗುವಂತ ಒಂದು ಪ್ರೆಸಿಪಿಟೇಷನ್ ಕನ್ವೆಕ್ಷನಲ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓರೋಗ್ರಾಫಿಕ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅಂದ್ರೆ, yes, if there is a mountain, let us say Western Ghats, and if there is wind that is flowing in this direction, wind that is advecting towards this Western Ghats, at this point wind ಗೆ ಏನಾಗುತ್ತೆ, it has no other option than to rise. Illi on its own, illi forced rise. Who is forcing this? A mountain. Mountain ಅಂದ್ರೆ oro, the term is orography, ಅಂದ್ರೆ mountain building. Orogeny, mountain building. If this is a mountain or any elevated area that's playing a role, that is forcibly rising the air mass, we call such a type of precipitation. Illi enagutte, because of this rise it will cool down, and again illi cloud formation agbiಟ್ಟು ಇಲ್ಲಿ ಮಳೆ ಬರುತ್ತೆ. ವೆಸ್ಟರ್ನ್ ಸೈಡ್ ಆಫ್ ದ ವೆಸ್ಟರ್ನ್ ಘಾಟ್ಸ್ has higher rainfall than eastern side, ಹೇಳಿದೆನಲ್ವಾ, right? Third, cyclonic precipitation. Does anyone know what is the meaning of a cyclone? ಸೈಕ್ಲೋನ್ ಅಂದ್ರೆ ಏನೋ ಒಂದು ರೊಟೇಟ್ ಆಗುತ್ತೆ, ಏನೋ ಒಂದು ಮಳೆ ಬರುತ್ತೆ, ಅಲ್ವೇ ಅಲ್ಲ. ಸೈಕ್ಲೋನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಅ ಲೋ ಪ್ರೆಷರ್ ಝೋನ್ ಅಷ್ಟೇ. ವೆರಿ ಸ್ಮಾಲ್, ದಟ್ ಟು ವೆರಿ ಸ್ಮಾಲ್, ಅಂದ್ರೆ ಒಂದು 50 ಕಿಲೋಮೀಟರ್, ಅದು ಸ್ಮಾಲ್. ಒಂದು 50 ಕಿಲೋಮೀಟರ್ ರೇಡಿಯಸ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ, ಅಥವಾ ಒಂದು 70 ಕಿಲೋಮೀಟರ್ ಒಳಗಡೆ ರೇಡಿಯಸ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಒಂದು ಲೋ ಪ್ರೆಷರ್ ಝೋನಿಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಲೋ ಪ್ರೆಷರ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ವಿಂಡ್ ವಿಲ್ ರೈಸ್ ಆರ್ ವಿಂಡ್ ವಿಲ್ ಫಾಲ್? ಕನೆಕ್ಟ್ ಮಾಡಿ, ಆರಾಮಾಗಿ ಕನೆಕ್ಟ್ ಮಾಡಿ, ದರ್ ಇಸ್ ನೋ ಹರಿ. ಲೋ ಪ್ರೆಷರ್ ಅಂದ್ರೆ the weight exerted is less. If the weight exerted is less, air molecules can rise. ಅದೊಂದು ಲಾಜಿಕ್ ಕನೆಕ್ಟ್ ಮಾಡಬಹುದು. ಅಥವಾ ಲೋ ಪ್ರೆಷರ್ ಯಾವಾಗ ಜನರೇಟ್ ಆಗುತ್ತೆ? whenever there is high temperature. ಹೈ ಟೆಂಪರೇಚರ್ ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಲೈಟ್ ಆಗಿ ಡೆನ್ಸಿಟಿ ಕಮ್ಮಿ ಆಗುತ್ತೆ, ಡೆನ್ಸಿಟಿ ಕಮ್ಮಿ ಆದ್ರೂ ರೈಸ್ ಆಗುತ್ತೆ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಸೊ ಆ ಪ್ರೋಸೆಸ್ ಅಲ್ಲಿ ಆಗುವಂತ ಒಂದು ಮಳೆಗೆ ಏನಂತೀವಿ? ಸೈಕ್ಲೋನಿಕ್ ಪ್ರೆಸಿಪಿಟೇಷನ್. ಅಂಡ್ ಫೋರ್ತ್, ಕರ್ನಾಟಕ ಅಪ್ಲೈ ಆಗಲ್ಲ, ಫ್ರಾಂಟಲ್ ಪ್ರೆಸಿಪಿಟೇಷನ್. ಫ್ರಂಟ್ ಇದು ಬೇಡ ನಮಗೆ ಇವಾಗ, ಬಿಕಾಸ್ ಇಟ್ ಹ್ಯಾಪನ್ಸ್ ಓನ್ಲಿ ಇನ್ 60 ಡಿಗ್ರಿ ಲ್ಯಾಟಿಟ್ಯೂಡ್. ಅಲ್ಲಿ ಏನಂದ್ರೆ ಎಕ್ಸ್ಟ್ರೀಮ್ಲಿ ಕೋಲ್ಡ್ ವಿಂಡ್ಸ್ ಫ್ರಮ್ ಪೋಲ್ಸ್ ಬರುತ್ತೆ, ಅಂಡ್ ಎಕ್ಸ್ಟ್ರೀಮ್ಲಿ ವಾರ್ಮ್ ವಿಂಡ್ಸ್ ಫ್ರಮ್ ದ ಟ್ರಾಪಿಕ್ಸ್. ಈ ಬಂದ್ಬಿಟ್ಟು ದ ಪಾಯಿಂಟ್ ವೇರ್ ದ ಮೀಟ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಫ್ರಂಟ್, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಅಂಡ್ ನೋಡಿ, ರೆಡಿಯಾಗಿ ನಾವೇನ್ ಅನ್ಕೊಂತೀವಿ ಮಿಕ್ಸ್ ಆಗ್ಬಿಡುತ್ತೆ ಅಂತ, ಮಿಕ್ಸ್ ಆಗಲ್ಲ. ಕೋಲ್ಡ್ ವಿಂಡ್ಸ್, ವಾರ್ಮ್ ವಿಂಡ್ಸ್ ರೆಡಿಯಾಗಿ ಮಿಕ್ಸ್ ಆಗಲ್ಲ. ಕೋಲ್ಡ್ ನೀರು, ವಾರ್ಮ್ ನೀರು ರೆಡಿಯಾಗಿ ಮಿಕ್ಸ್ ಆಗಲ್ಲ. ನೀವು ನೋಡಿ, ಯು ಹ್ಯಾವ್ ಟು ಮೇಕ್ ಸಮ್ ಎಫರ್ಟ್ ಟು ಮಿಕ್ಸ್ ಇಟ್. Until that equilibrium temperature is reached, mix agalla, correct along. And such a point of time, cold wind being heavier, cold is heavier, right, will always stick to the ground. Warm air is lighter, will be forced to rise. Allo ಒಂದು ಮಳೆ ಆಗುತ್ತೆ, ಅದೇನಂತ ಕರಿತೀವಿ? ಫ್ರಾಂಟಲ್. ಎಕ್ಸೆಪ್ಟ್ ಫ್ರಾಂಟಲ್, ಕನ್ವೆಕ್ಷನಲ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗಿರ್ಬೋದು, ಓರೋಗ್ರಾಫಿಕ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗಿರ್ಬೋದು, ಸೈಕ್ಲೋನಿಕ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಆಗಿರ್ಬೋದು, is applicable to the state of ಕರ್ನಾಟಕ. ಸೀಸನ್ಸ್ ಗೊತ್ತಿರಬೇಕು, ಇನ್ಫ್ಲೂಯೆನ್ಸಸ್ ಗೊತ್ತಿರಬೇಕು, ಫಿಸಿಯೋಗ್ರಾಫಿ ಗೊತ್ತಿರಬೇಕು. ಕರ್ನಾಟಕ ಕ್ಲೈಮೇಟ್ ಇಸ್ ನಾಟ್ ಅಟ್ ಆಲ್ ಅ ಚಾಲೆಂಜ್. ಓಕೆನಾ? ಏನಾದ್ರೂ ಕ್ಲೈಮೇಟಾಲಜಿ ಬಗ್ಗೆ ನೀವು ಓದಿದ್ರೆ, ಬೇರೆ ಬೇಸಿಕ್ಸ್ ಏನಾದ್ರೂ ನಿಮಗೆ ಗೊತ್ತಿದ್ರೆ ರಿವೈಸ್ ಮಾಡ್ಕೊಂಡ್ ಬನ್ನಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಗೆ ದಯವಿಟ್ಟು. ಇಟ್ಸ್ ಗೋಯಿಂಗ್